Hey, what's up, guys? Welcome back. So I just want to talk through a little bit about the Pendulum Lab here. So you don't have this sheet, so I'll have this in this video, but definitely something you want to know about. So when you're doing your Pendulum Lab, so the first thing I need you to do is make a pendulum, which so you want about a meter of string or yarn or thread would work as long as stuff that's too heavy. I think maybe an arm's length or something that's longer than a meter, but that would definitely be a good way to start. And then you've got to think about what can you tie onto the bottom. We need three different masses um, that aren't the same. So, like I was thinking, maybe a water bottle that you just tied around the top, and then you put a little bit more water in each time. That would certainly work and be an easy one to do it. I've had kids at school before we've used washers, so like go with screws. So you maybe use three washers and six washers and nine washers if that's something you have. If you have a tennis ball that you can put a hole through, you could tie it to it. Different things like that. So use your imagination a little bit, get a little creative, and just try to think what you could tie that to the bottom of the pendulum so that it swings. And then one of the goals for us is we're really looking at what's called periodic motion. And so periodic motion, we haven't talked about this before. So what you need to know is that this is a regularly repeating motion. Oops. So it's stuff that happens over and over. So like a pendulum is going to go back and forth, or if you pluck a guitar string, it vibrates up and down and keeps repeating like that. So those are good examples of periodic motion. So it just means that it's repeating. And so you'll have to determine what's called the period of your pendulum. And so let's look at how we do that. So the period is the time for one cycle. So it's measured in seconds. But what you guys would have to do, so you'll pull your pendulum back and it'll swing to one side and then back to its original position or close to it, right? And that's the period, is the time for it to go there and back. Not just there, because that's not the full motion. So to come back to where it started or, close to it. And so we'll look at in the lab in a second what you'll do to determine that to kind of reduce our error. But the period is the time for one cycle. And then we also want to think about what forces are at work with the pendulum. So obviously gravity is at work, but the pendulum doesn't fall down. So gravity is always pushing downward, straight downward towards the earth, the force of gravity. And then what keeps the pendulum going in this path, like this, maybe you can guess it right now, is the tension in the string. So there's a tension force that is uh, from the string. It's not, I was going to say it's in the opposite direction of gravity, but that's not true. And right, because here where the force of gravity is down, the tension is this direction in the string. So not always the same direction, but always, just like we looked at with the orbits in class on Monday and Tuesday, there would be a component in that direction. So, just think about that, what forces are at work. And then let's take a look at the lab itself. So you get your pendulum all set up, and you may want to just spend time on Wednesday. There's a bunch of pre-lab questions, so you obviously have got to watch this video first. Um, and so you'll go through pre-lab questions. It seems like a lot. It isn't, because these are pretty fast, but it just gets at remembering some stuff we've done. So you'll want to answer those and let me know if you have questions, or we can talk about them in class on Thursday or Friday. And then what you're going to do, hang the lightest mass that you have with the string so the length of the pendulum is constant. All that means is you just use the full string that you've got and attach the lightest mass to it. Pull it back about 45 degrees. Don't get a protractor out to do this, but just kind of eyeball what 45 degrees is. And obviously you've got to tie this to something that you can swing it from. If you don't, maybe you get somebody to hold it up at the ceiling or something like that, and so that you can swing it. And you're going to let it swing for 10 seconds. Okay. So I'm sorry, we're not going to swing it for 10 seconds. I'm going to change that. Let it swing 10. Let's do 5 times. Sorry, I'm getting ahead of myself. I missed this. So let it swing 5 times. Um, record. Let's record the time for that. I missed this in editing. And so repeat that. Change the data table. You'll do that 3 times. So now what you'll get is an average time. So let's say to do 5 swings here, it was 8 seconds, 9 seconds, 9.3 seconds. So average those. So what you've got to do is think about, okay, if it took, let's say, 20 seconds for 5 swings, then it was 4 seconds for 1 swing. So to determine the period here, make sure that this is the time for 1 swing. So that's the key thing. And we want to let it swing 5 times and time that, because then we get a better average there. Because sometimes the start and stop of doing the timer on your phone, it gets you some error there. So repeat that with the next lightest mass, and then or the largest of whatever 3 masses you're using. So I put here objects used. So like, though I think the water bottle is a great idea, so I might put like water bottle with a quarter full, half full, 3/4 full, something like that, or if you're using different stuff, just whatever you use there. And then let me just copy and paste this. So now with the second part of this, what we're going to do, you're going to use the middle mass. So whatever it was that was not the heaviest, not the lightest. So again, I'll use the water bottle example, the water bottle half full. And you've got your pendulum set up the same way. You know what you could actually do that I'm thinking about it is whatever this data is going to be this data. So you copy and paste. It saves you one trial, but whatever. So you're using the middle mass with the length of the pendulum at its longest. Let it swing, do the same thing, figure out the period. And then you're going to shorten the string. All right, and here's where it's hard for us to do this at home because everybody's got different things. So I don't know what length you're starting with, but try to make it 20 to 30 centimeters shorter. So 38 is roughly or 30 is roughly a foot. So, just think about making it, shorter by this much if you can. And then you're going to shorten it that same amount again. So what we're really doing is getting the pendulum to be 3 different lengths. We're not changing the mass in part 2. So we're just changing the length of the pendulum, and we're seeing what that does to the period right there. And there's pre-lab questions about those, about what you think is going to happen. So we'll do those, get your data, figure out your period. So, and then post-lab questions. And so take a look at those. So, some of you I know are more ambitious than others. So some of you may get a ton of this done today, Wednesday, and be mostly done with it. And then some people will maybe want to ask some questions on Friday and or Thursday whenever you have class, and we'll go through that. But ideally, what you would accomplish on Wednesday is get your stuff together to set the pendulum up, answer the pre-lab questions, and maybe get the data. But realistically, if you get all your pendulum stuff together and then do the pre-lab questions, the only hour that would concern me is 6 hour. You just would have, it's just a quicker turnaround. You just have to make sure that you're getting your work done really quick on Friday. So yeah, and after watching this, let me know if you have questions, and we'll get those cleared up. And if you absolutely have nothing for a pendulum, then I'll want you to let me know that too if there's no way for you to set that up, and then we'll have to figure out a way to get you some data. So cool. I will see you in class. Be good.